All right, these are the extra examples from section 3.4. So we're going to go through those. So we're doing A part and C part for example 3 on section 3.4. We were listing all of these different evaluations of the function. So we're looking at f of a, which in this case for this function would just be 3 minus 4 times a, because we're switching the x for the letter a. F of negative a would be 3 minus 4 times negative a. In that case, we do actually have something we can do. We can multiply the negative 4 and the negative a together, which makes that positive 4a. Then we have negative f of a, which remember we said is like negative 1 times f of a, which was our first answer right here. So that would make this negative 3 plus 4a. Then f of a plus h, which is a binomial going in for a spot that was a monomial originally. In this scenario, we need to distribute the negative 4 to both of them. So 3 minus 4a minus 4h. Then we have f of a plus f of h, which would be f of a, which is this one, plus, and then we do f of h, which is the same thing as f of a, except you put in an h for the variable. And then we combine like terms, so that'd be 6 minus 4a minus 4h. And then finally we had this difference quotient right here. So f of a plus h minus f of a all over h. We have the a plus h right here, so we're going to write that on top as the first part. So that's 3 minus 4a minus 4h. And then remember, you don't need to worry about this negative because if you use negative f of a, it's already taken care of. So you just write negative 3 plus 4a using the answer from this part all over h. Our 3's cancel, our 4a's cancel, we get just negative 4h over h, which is negative 4. Then we're going to look at C, which is a little bit more difficult. We're going to do the same evaluations on it. So f of a is 2 times a squared plus 3 times a minus 7. So pretty much nothing to do there, just write it as 2a squared plus 3a minus 7. Then we have f of negative a, which this time you're going to plug in a negative with the a. When you square it, you get positive a squared times 2 would still be 2a squared. 3 times negative a would be negative 3a, and then the minus 7. So notice the middle term changed in this scenario. Then we have negative f of a, which would be negative 1 times f of a, which was, remember, the answer from our first part. So that makes that negative 2a squared minus 3a plus 7. You're just changing all of the signs. The one that's the most difficult here is f of a plus h, because we have to do 2 times something squared plus 3 times something minus 7. Each of these little something spots is an a plus h. So the reason this is more difficult is you're going to have to FOIL this one because it's being squared, and then you have to distribute some stuff. So this would be 2, and then we need to do a plus h times a plus h. Go ahead and distribute this 3 if you would like. That'd be 3a plus 3h minus 7. On this one, I would FOIL this first, so that would be a squared, ah, and another ah would be 2 ah's, and then h squared. Bring down everything else. And then we would distribute the 2 out front. And notice that none of these are like terms. Nothing has exactly the same variables. So that would be the answer to that one. Then we would want to do f of a plus f of h, which is just 2a squared minus, or is it plus, sorry, plus 3a. Minus 7. plus the f of h, which would be 2h squared plus 3h minus 7. And the only like terms here are the negative 7s. So we'd have 2a squared plus a 3a plus a 2h squared plus a 3h minus 14. And it doesn't matter if you write these in descending order or not. So, and then our last part, remember, is the big fraction that combines some of those. So f of a plus h minus f of a all over h. So sort of do this one over here to the side. We would take the f of a plus h, which is this big long answer. That's going to be part of our top. It's kind of long. And then also on top we have negative f of a. And that's all over h, so I ran out of room, so I had to stack some of that. So the a squareds are going to cancel, the 3a's are going to cancel, and so are the 7s. So you're left with 4ah plus 2h squared plus 3h all over h. And everything has an h, so it's going to reduce down by 1. So this would be 4a plus 2h plus 3. And that's it for that example. Okay, so if we scroll down, our next one that we skipped over was a domain and range of a picture. So this one right here, we wanted to do the domain and range of this picture for part A. And then we also wanted to answer the question f of 1 equals what? And what x values let our y equal 1? Whereas this is x. Okay, so the domain here, you have to be careful because these aren't labeled like the other one was. Your smallest x value that you have an ordered pair attached to is -4, and it is included because this is closed. And then you get up here to -2 and you think, oh, do I have a gap? Well, as long as both of these have, if they both had open circles, you would have a gap because that would mean that -2 was not being used. But because -2 is being used on the top, we do actually include this and we keep going. So we have -1s on the graph, 0s on the graph, 1s on the graph, and that looks like that's the end. So our domain runs from -4 to 1. That is the x values that are being used. Our range, remember you started your lowest y value, which looks like it is -4. And notice we go up to -1, and then we have a gap. There are no y values from left to right on our any ordered pairs. There's a whole gap here vertically. So this would end at -1 with a parentheses this time because it is an open circle on that specific point. And then we'd union up with where we start again, which is at +1, and we go up to +3. And both of these are closed circles, so that range would have brackets on it. So there's my domain and range. My domain goes from -4 to 1. That's what x's are being used. And then there's two separate y chunks for the graph. F of 1 means find 1 on the x-axis and find an ordered pair that goes with that. The y value for that guy is -4. When you say f of x equals 1, you find the y value of 1 and you draw like a little dashed line all the way across and you see how many times did your graph cross that line. Well, we only crossed it once or touched it once, and that was at the point that has an x value of -2. So the x value that goes with that one is -2. Okay. The next questions had to do with finding the domain of functions that we know, and we looked at a couple of these together. I'm going to do the last two that we didn't do. So that was part B and I believe part E. So for part B, you have to look at this as this is a radical function and it's also an even root. So your domain has to have the inside part staying greater than or equal to 0. The problem with this is that there is a polynomial now that has an x squared in it. So anytime you have a polynomial underneath a radical that is x squared or higher, you're going to have to deal with the chart method to see when is it really greater than or equal to 0. So we factor this into x plus 5 and x minus 5. So we have critical values of -5 and 5. We place those, remember, on a number line for our chart, smallest to biggest. And they're both closed circles since they are equal to and they're not in a denominator. So this would be -infinity to -5 and -5 to 5 brackets and then 5 to infinity. We pick a test value in each region, so -6, 0, and 6. Our factors are x plus 5 and x minus 5, and we are hoping to be greater than or equal to 0. So this would be a negative and a negative, which multiplies to make a positive. 0 would be a positive and a negative, which makes a negative. And 6 would be a positive and a positive, which makes a positive. Greater than or equal to 0 means positive, so there are two regions in our domain. -infinity to -5, bracket, union with 5 to infinity. What's interesting about this one, and what I'm going to show you, because this one's not usually one we would put on the exam, it's a little bit difficult because of the combination of two different sections of notes. But if you go to Desmos and you actually put in the picture of that graph, it's a kind of interesting looking picture. So I wanted to show you what this graph looked like so you could see that those domains actually make sense. So it's y equals the square root of x squared minus 25. If you notice on my picture here, and I'll make sure that I can zoom out a little bit, there's no graph between -5 and 5. All of the graph is on the outsides, which makes sense with our domain. So the graph is completely undefined here in that middle section. Okay, and then the other one we skipped on the notes here was E. So this is a combination again. This is a rational and a radical. The only difference here is that normally our radicals, remember for our even roots, just write a little side note, we let the square root part, whatever's inside, be greater than or equal to 0 to keep it from being imaginary. Well, because this is in a denominator, you have to keep it only greater than 0. We do not want a denominator part to equal 0. So that's the only difference here, is that if the radical shows up in the bottom and it's a square root or a fourth root, an even root, you don't let it equal 0. You just do greater than 0. So I'm going to set that part up first. So x plus 3 has to be greater than 0 to keep this from being 0 or an imaginary number. So that means I have to be greater than -3. And then this guy tells me that x cannot equal 3, or this part would equal 0. So if you think about that on a number line, here's -3, we're shading this way forever. 3 is to the right of that. So there's going to be an open circle for the number 3 that we're going to skip over. So my interval notation would be -3 to 3, union with 3 to infinity. Okay, there were two other questions left on the notes for this. I already showed you what the difference quotient picture looked like. This is that formula that we were doing in the evaluation ones. The way it's going to look on the test is slightly different. Instead of the letter A, they use the letter X just to match with the functions a little bit better. So I'm going to show you how to do one from scratch where you don't have all those other evaluations that you've done right away. So the first thing you would notice is that we need to find these two parts. We're going to do f of x plus h, and then we're going to do negative f of x. So f of x plus h using this function right here. So this would be -2 blank squared plus 3, and in that blank we put x plus h. We FOIL that out because it's being squared. So that's -2, and then this would be x squared plus 2xh, because you get xh and xh again, plus h squared, and then plus a 3 at the end. We distribute this -2. Hang on, my PDF is having a little bit of trouble, so give it a second to load. There we go. So minus 2h squared plus 3. Notice this didn't get the negative 2 because it was outside of the parentheses. So that's going to be this top part of this fraction for the first part of that evaluation. The second thing we want to do is negative f of x. Negative f of x is really easy. You just put a negative sign in front of the original function and you distribute it. So that would be 2x squared and minus 3. So this part right here and this part right here are our numerator for this formula. So we're going to put on top, and I'll scroll down a little bit, f of x plus h minus f of x over h is negative 2x squared minus 4xh minus 2h squared plus 3. Then we write this part, plus 2x squared minus 3 all over h. The 2x squareds cancel, the 3's cancel. You get negative 4xh minus 2h squared over h, and you should have h's that reduce out of each part. Excuse me, that's not a plus, it's a minus. Minus 2h. And that is it. So same thing we were doing before, except you just have to do the f of x plus h and the negative f of x. And remember, you just pull that out of the formula from the directions. Okay, and then this very last one is actually tied back into section 3.3 on the lines. This says, if a linear function satisfies the given conditions, find f of x. So they're looking for, because they said linear, we're looking for f of x equals mx plus b. That's how I know that I'm looking for this. It's because of the word linear. And if you remember what I told you at the beginning of section 3.4, these are ordered pairs. So this is negative 2 comma 7 and 4 comma negative 2. So I would write my slope formula first. So negative 2 minus 7 over 4 minus negative 2. That is negative 9 over, that'd be positive 6. Reduce that down to negative 3 over 2. And then use one of the ordered pairs. You can use your point slope formula next. Using one of your ordered pairs and your slope, you can find your equation. So y minus 7 equals negative 3 halves. X minus a negative 2 would be plus 2, so I'm using this point. Then I would multiply both sides by 2 to get rid of that denominator, and then you can distribute the negative 3. And then I'm going to solve for y. So 2y equals negative 3x plus 8. Divide everything by 2. And then they want it written as a function. So your final step is to change the y back into the letter f of x. F of x stands for the y coordinate. And that's it. So that is all for section 3.4.